Good morning, good afternoon, or good night, depending on where you're joining us and where you're tuning in from. And welcome to the AOT community meeting and Tech Bytes. It's an online series bringing the AOT community together wherever you are in the world. And the goal of the series is to create connection and bring about connection in our community of ocean technology practitioners, scientists, fishers, you name it. So thank you for being a part of this movement to help make our oceans more accessible. So here is the layout for today's call. First, we'll be giving a brief community intro and update. Then we'll roll right into our tech bite. We'll be hearing from our lovely featured speaker, Titus. And then Tech Bites is intended to be bite-sized, so we'll have about 10 minutes for the talk and 10 minutes for questions. And then after Titus's talk, we'll be breaking into breakout groups for 15 minutes. And depending on how many folks are show, well, it might be tailoring the breakout group size. Um, but the breakout groups are intended for a space for connection. So, to start off, just for those that are new here to the call and new here to these meetings, we wanted to align on what we're really doing here today. So, we're all focused on making our oceans more accessible, where this term accessible ocean technology comes into play. And from numerous working groups and from many of the folks here on this call, we came to the conclusion that AOT encompasses cost-effective technical solutions to increase ocean observations, also avoiding terms such as cheap and even sometimes low cost when it conjures up different feelings. So these efforts already exist around the world and are not something new. But what has been missing is connection. So we're here today on our second online gathering, and we'll hope to continue these online gatherings and gather more and more individuals to meet kind of asynchronously outside of conferences, etc. So before we hop into the Tech Bite call, component of the call, one part that is key is connection through updates. So our next moment to get together in person will be at the Ocean Sciences meeting in February. And so one thing we wanted to ask the room and to poll the room is, will you be at Ocean Sciences meeting in February? So I'll launch that here. You guys can fill out yes or no. The intention is that we'll be hosting an ocean outcome session there, and also there'll be plenty of lovely sessions from some of our friends, including Deuce and ODL, but also perhaps we can gather in person as well in that space. So,
Yeah, I wanted to add to that. We do have it. I just kind of found out yesterday that we are doing an informal gathering with like a social hour with ODL and Blue Robotics on Thursday night. We don't have the time, but just keep that in mind.
oh, lovely. Okay, thank you, Amy. So in addition to that update, we also want to hear from the room as well, if there's any AOT related news or events from the circles that you would like to share with the room, and we can also share them out as well.
I can add one. Titus, you will not know me, but I think most of the other folks in the room know me. But I'm part of the Integrated Ocean Observing System in NOAA, and we have a program called the Ocean Technology Transition Program, which is very much to take the kinds of technologies that are being developed in this community and work to transition them to get them to operational, especially within the United States and within NOAA. And we, after much work, hope to have a funding opportunity on the street within the next, could be days to weeks, but sometime, let's say in the next couple of months, looking at likely a mid-May or mid-June due date for proposals. There's a slight chance we would do it on a much faster timeline with them doing mid-February, but time is that clock is ticking so hard. I think probably we won't make it for then. But definitely we are aiming for mid-May or mid-June. These are 3-year projects. Total of 1.2 million over the 3 years, so up to $400,000 a year. And we're usually able to fund about 5 to 6 proposals of the circa 25 proposals we get, 25 realistic proposals we get when we put one of these out. So reasonably good odds. And I will definitely keep you guys posted and give you all the information, but I'm also trying to get the word out just that these are coming. So.
Oh, that's lovely, Tiffany. Yeah, that's lovely. And please let us know. We'll share it out in all the email channels that we have. Yeah. Colin, I see your hands raised as well.
Thanks, Jess. Yeah, just wanted to note for any of those folks that are going to Ocean Sciences, there's beyond the AOT Ocean Outcomes session that we will have. I'm also a part of a group that's hosting a Queer Ocean Sciences Town Hall. That's going to happen on Tuesday during the lunch hour. And then that evening, there's a rainbow reception as well. So any of those are interested, please join us.
Ooh, lovely. That's lovely. Thank you, Colin. Frank, please go ahead.
Yeah, just wanted to introduce myself. At the University of South Florida, College of Marine Science, but I'm representing the Marine Biodiversity Observation Network, which is also very closely linked to IUS at NOAA, but it has an international representation with a secretariat in the Azores and one in Japan. It also has a presence in Europe. And we're interested in anything that lives, that moves around in the ocean. And so accessible technologies is very much part of the effort here, from omics to acoustics and satellite data to other kinds of imaging. And so we have a webinar series under the Marine Biodiversity Observation Network umbrella. And we've had a couple seminars on accessible technologies. So I'm curious about this group, which I didn't know, but certainly interested in seeing how we can contribute or collaborate.
Lovely. Thank you very much, Frank, for the intro. And also, I feel like there will be a lot of intersecting pieces as we go forward.
Yeah.
Lovely. Well, if there's any other news that folks wants to share, otherwise we'll get to our tech bite tech talk speaker. We'll also iterate on that term as well. All right. Well, then let me welcome to the stage and it's an honor really of welcoming Titus to the floor. So Titus Canete is a program manager for the Large Marine Vertebrates Research Institute, Philippines, and is one of the first AOT working group contributors back in September 2023 in the Deuce in-person accelerator. So Titus is a marine biologist, a deep sea ecologist, and also leads Lemov's deep sea shark research and conservation project. He works to explore and protect the deep water ecosystems in the Philippines and was recognized in 2025 with the National Geographic Wayfinder Award for his commitment to accessible ocean science and inclusive conservation. So he'll share how locally driven innovation is transforming deep sea research and shark fisheries management. So we're all very excited to have Titus here today. So please, Titus, take it away. We'll
Thanks so
stop my
much,
screen
Jess.
share.
Thanks. Hi, everyone. It's great to be here, and thank you for joining us wherever you are in the planet. It's great to be able to have this opportunity to share the work that we're doing in the Philippines and trying to make deep water technology or ocean technology in general more accessible. This could be through development or just really lowering the effort or cost it takes to have access to these equipment and the technology in order to conduct research in both shallow water and deeper water marine ecosystems. Just a quick background about me. Hi, my name is Titus Canete. Jess, you nailed my last name. That's really cool. We get a lot of people who mispronounce it, but yes. I'm based here in the Philippines, and I have been doing marine research for a while now, and specifically, my field of expertise would be that of sharks. I work with an organization called the Large Marine Vertebrates Research Institute Philippines. We're a small non-government organization here in the Philippines that study marine megafauna. When we say marine megafauna, we include sharks, rays, turtles, whales, dolphins. If it's big, has a vertebrae, and you find it in the ocean, we're likely studying that animal. Have a vision of really having a secure and prosperous ocean, not just for the marine life, but also for the people who depend on it. Majority of the Philippines protein source is really reliant on seafood, and if we can't protect these ecosystems and the indicator species and the species that make up these ecosystems, is that will eventually going to be affecting human population down the line. We want to protect marine megafauna. Um, and we do this by investing on local people, building ocean leaders. We want to provide science-based tools. This can include technology, in order to support, the sustainable management of the marine resources that we have here in the Philippines. And hopefully it's something that can inspire even other countries to participate through the access to these tools. People will be able to access data, which will then support the effective management or the sustainable management of these ecosystems. And we want everything that we want to do, we want to be science-led. We believe in teamwork and innovation and being responsive, but also because of the changing times and the very high unpredictability of times right now, we also want to be flexible in the things that we do. So we have this general idea of what sharks are, and I guess a lot of individuals may not understand as to why we're studying sharks. But sharks actually play very important roles in us as humans, but also like in our ecosystems. They help balance food webs by keeping prey populations healthy. So our sharks are actually indicator species that say that marine ecosystems are healthy when we see these sharks in them. In a lot of countries, the Philippines included, there are socioeconomic roles as well that they play, including sustainable tourism when done correctly. So we have like manta ray festivals and whale shark festivals in certain areas of the Philippines, which value these species for their tourism roles. They have a cultural significance in the country and other countries. You can see in the Cook Islands and here in the Philippines as well, we've incorporated sharks into our banknotes. We have legends about the sharks. We have myths. While it's discouraged, there are also traditional medicines that believe that sharks heal certain ailments. There is a cultural significance of sharks as well. And they also inspire technology and scientific value in the medical field. They're looking into creating surfaces that replicate shark skin, in which they believe that bacteria will have a harder time to attach to a surface when they replicate the shark skin. There's research on Greenland sharks that are looking into their longevity and to try to see how it can be replicated in human populations. So how to live longer, basically. But it's not all sunshine and rainbows for these species. A third of these sharks are threatened with extinctions, and over the last century, especially through fisheries, they've had a significant impact on sharks, which is compounded by habitat loss and climate change. So sharks are one of the most threatened taxon in the marine environment. They're only second to amphibians on a global scale. So that's basically why we study sharks. And I want to take you to one of our research sites here in the Philippines. This is actually in my home region in Bicol. We have this area called the Ticao-Boreas Pass Protected Seascape. And within this seascape is a seamount, which we know as the manta bowl. And why we call it the manta bowl is because in the shallowest part and the tip of the manta bowl is actually an aggregation of manta rays. So these are vulnerable mobulus species. And we found through our research in the manta bowl this is the area with the largest known manta aggregation in the Philippines. Thanks to their significant patterns in their bellies, we're able to identify whether these individuals have been into the area or if it's a new individual. And we found that these species use this area as a cleaning, feeding, and courtship station. And we found that there's also connectivity between the Mantible and other sites in the Philippines. How we were able to do our research is thanks to an accessible piece of tech, pretty low cost, called the RUVS or RUVs. So basically, this is a GoPro or any action camera, a battery pack inside a watertight tube, um, which we leave on certain stations of the reef in order to observe the populations. And through the use of this highly accessible tech, we were able to identify that there's over 183 individuals from 2018 to 2020, but we believe that we have at least 235 individuals now in the Mantle. This is still to be updated because we had to stop our research during the pandemic. But yeah, we're able to find that there's so many mantas that are using the manta bowl. We found that there's a higher proportion of males in the manta bowl as compared to females. Um, and we've also found that there are certain peaks where you have a higher chance to see these mantas. So this is all through the use of, accessible technology. But not only did we find about manta behavior through the use of this technology, but we've also found that there's also other marine megafauna that are present within the area. These include whale sharks, endangered species such as pelagic thresher sharks, white tips, spotted eagle rays, and even critically endangered species like the scalloped hammerhead. We found through both the use of the tech and through interviews that there are still threats to the manta bowl, such as the illegal catch of these protected and endangered species, such as there was around 219 thresher sharks that were landed in 2019 and about 94 landed in 2020. And we found that there are external pressures and threats to the manta bowl, which include the accidental catch of these endangered species, such as thresher sharks, or there's also targeted catch. We believe there's still targeted catch for these sharks, overfishing, marine debris. And this can also be seen in some of the footage that we've collected in our video systems. We've seen entanglement, we've seen injuries, we've seen ghost nets covering some of the reefs in the manta bowl. This is the footage that was collected in one of our RUVs, and you can see that one of the mantas is towing this nylon fishing line. And what this does is besides giving injury to the pectoral fin of the manta, it's also creating drag and it's taking more energy for it to swim. So it's really affecting the population here in the manta bowl. Here's from another station of another manta bowl carrying the same line. We've also been able to identify that there are external pressures like anchors that are dragging through the reef. And this would not have been possible had this accessible technology not been present. So there are currently movements as to how we can better protect the manta bowl because as of today, the manta bowl, while it's a protected area, it is currently a multiple use zone, meaning anyone can do anything at any time. So there is currently a movement to better protect or have better zoning for the area. And we're still seeing like bycatch of sharks and mantas, mobulas in the area. We've recently worked with the National Geographic Science Exploration Lab for their critter cams. And this is basically a camera that you attach to a manta to kind of see perspective from the eyes of the manta. So it's something that attaches to the back, and after a certain amount of time, it detaches so we can look at the footage. So this technology actually has some sensors here to also look at the depth and the temperature of which the manta is diving. And we found that the manta rays don't just stay in the shallow areas of the mantle, but they actually go quite deep. This was one of the tagged mantas that we've seen, and we actually saw it go to around 217 meters at depth. So it stayed there for about 30 minutes before coming back to the mantle. And we know that 200 meters and below would be considered deep sea, which is interesting because majority actually of Philippine territorial waters can be considered as deep sea. However, we don't have much information about these ecosystems. One of the reasons being that we don't have access to the technology or the expertise in order to study these ecosystems. So that's kind of the the barrier that we're trying to break through right now is creating accessible ocean technology. Here we have our low-cost deep sea camera system. It's a baited remote underwater video system, and it took inspiration from the National Geographic deep sea camera systems, where it's attached to a biodegradable weight, and after a certain period of time, it corrodes a wire or burns a wire and sends it back to the surface. Ours is a very low cost version of it. It could be done with a GoPro and a battery pack in it, and we just have a system using a simple Arduino system to cut the wire and bring it back to the surface. This is footage of our first, I would say, deep sea drop. We were able to get to 188 meters, so only a few meters short from deep sea. But it does show that this tech is possible and it works. We had the Ocean Discovery League's Macanu attached to it, and we were able to see for the first time ever that in the deeper areas of the mantle there are actually mesophotic reefs or deep sea reefs. So it's interesting to see these ecosystems for the first time, and really through accessible ocean technology, this is possible. While we haven't seen the sharks or the mantas yet approach our cameras, we have seen a few critters, such as deep sea eels. But we do think that we need to increase the soak times in order for us to see these animals who have never seen the light at this depth before. So while we have seen some answers through the accessible ocean tech that we have as of the moment, we still have some questions like, how do we integrate deep sea ecosystems into the zoning? And if we have these zones that, okay, deep sea ecosystems are included in areas that are going to have bigger protection, how exactly are we going to manage it? Exactly are we going to manage it? What tools do we have in order to monitor these ecosystems? We want to find out what the mantas are doing at depth. So we will definitely need some more deployments, and we want to know what else is down there. And I think one of the issues here in the Philippines, and a lot of areas across the globe actually, and one of the biggest threats to deep sea ecosystems is just because we don't have a lot of information about it. And in countries like the Philippines, because there's not a lot of information about it, there's no value or appreciation as to these ecosystems. And because we don't value it, we don't invest in it. We don't have tools. We don't invest in protection. So that's really one of the barriers that we want to kind of address is, increasing the appreciation for these ecosystems and how can better protect it through giving access to these ecosystems. And I think this is my last slide. So the images on these slides, I think, capture the essence of what we strive for. Other than increasing the accessibility to the technology, it's also creating deeper connections. A lot of people in this room I've gotten to know thanks to the deep sea, like Jess, Colin, Amy, and a lot of people I bet who are going to look at this call later these are deep connections spanning across various dimensions. between researchers and local communities, between technology and traditional knowledge, and ultimately between humanity and the ocean. So our mission is to protect and explore our deep sea environments, but we know this is something that we can't do alone. So I'm so grateful for the Accessible Ocean Tech community because this is a collective effort. And by making deep sea research accessible through low cost or more affordable technologies, I believe that we can bridge gaps, we can inspire new generations, and ensure that no community is left behind in the quest to understand and preserve our oceans' depths. So, yeah, access to tech provides the power to protect. Thank you so much, and I'm sorry I took up longer than I should.
Wow, that was I love the ending too. It's like a mic drop moment right there, Titus. Well, wonderful. We have time for questions, so please, if you guys have any questions, unmute and ask Titus. Otherwise, I'll start off the question cycle.
I,
Oh, sorry. Okay, Tiffany, please go ahead.
Good. I'll just start with a small world one. Doris is one of the projects for funding, and so it's good to hear. It's good to hear that you're actually using it and getting good results from it. I guess I'll ask that open-ended question. What do you wish it did that it doesn't do now?
Sorry, Tiffany, Doris.
Or the deep sea camera?
I see. We currently don't have access to Doris yet, but we
Okay.
do have the predecessor to Doris, which is the Makanu. And
Oh, sorry,
from
Makanu. Yeah, sorry. That's yes. Sorry, they're working on Doris, but
yeah,
you have Makanu.
yes, but we hope to have access to Doris soon. Yeah, we love the Doris. I think I mean, compared to our GoPro system, we were actually surprised, but it actually does better low light camera capture than the GoPro, maybe with the current settings that we have. I think the Makanu is great in that it's easy to deploy, but it needs it needs I would say it's not complete yet. It needs I guess this is where Doris is headed, is that uh it still needs some sort of attachment in order to actually be deployed. It needs a rope, it needs a frame.
Right.
Whereas with a Doris, I guess it's a more complete system where it has buoyancy that brings it back up. It has its own release system. So I guess that's the only thing that I was looking for in the Makanu. But the Makanu is great, I think.
Yeah.
And to be able to compare it with our system, it's a truly an inspiration that you have all these sensors in this small tube that's easy to carry around. It's easy to charge. It's easy to get information out of it because it's wireless, so you never have to open anything. So I do like the how um, simple it is to use the mechanism.
Cool, thank you. It's always good to hear from a user because you hear from the proposer and they're like, it can it can do everything. It can wash the dishes and make dinner and everything. It's always good to talk to somebody who's actually used it and say, yeah, actually, it does make dinner and it makes a decent dinner. So thank you.
Thanks, Tiffany.
Colin, you want to hop in there?
Sure. Yeah, it's piggybacking a little bit on what Tiffany was asking. But Titus, I was curious, what other, so visual data is obviously super powerful. What other data within your program do you think you would like to have or would help to fill some knowledge gaps? Um, and then I guess piggybacking on that, then what does that look like as far as potential technologies that would help to fill those gaps?
hmm I mean, Colin, uh, right now, one of the projects that we're looking into is really looking at acquiring deep water environmental DNA.
Okay.
So we're actually looking at tools that can sample or collect samples from deep water without getting contaminated from shallower waters, like, back on the way up or going on the
Right.
way down.
Right.
So environmental DNA will be definitely one of them. Um, I also think that currently we're limited to stationary stations. What I mean by that is that these cameras are great because you can reach the deep sea, but the area coverage is quite low as compared to an ROV or something that can move. So we're looking into maybe having access to more systems that have or can cover a wider range of area as
Hmm.
compared to these stations. While there is a value of having stationary deployments, as some animals might not come close if something is moving. Um, but these have to go hand in hand. I think the more data that we have, whether it's temperature, salinity, environmental DNA, better imaging better footage of the deep sea ecosystems. I think the more information that we have on these ecosystems, then the better we understand these ecosystems, then the better we can find ways to protect them um, to manage these ecosystems.
Hmm.
We also want to see if we can have longer term monitoring stations in the deep sea, kind of see how the quality or if there's any deterioration of the ecosystem. So we're definitely looking for more sensors, for more um, data, basically. But we'll start for the basics first and try to get a camera down there.
No, that's awesome. Thank you for your answer. And we should definitely follow up on some of the things that you mentioned. I think the Palau work could potentially be a good match for being able to use some of the same systems in Philippines or in the Mantle, wherever you want to deploy them.
Thanks, Colin.
Sweet.
Wait, Colin, do we have a way to, and plus, do we have a way to get a DNA device down there, collect, close it up, and pop back up? At this point, it's all passive, but it has to go through
Yeah, everything we have through Synchro is passive at the moment, but there are devices and um, we can apply for funds to be able to get a system to you. I think that would be, yeah, very doable.
That
um,
would be great.
I know, right? We'll be in touch. I have, so my question, and it's more just about, it's not just the maybe the rubs as well, the rubs and the Manta device that you had on there. Is it easy? How is it for replacing parts? I know that's part of the whole accessible tech, but has that been all pretty accessible in the Philippines to replace anything or get things
Well,
shipped?
I think for the rubs, I mean, these tubes, they're blue robotics tubes, and the
Oh, okay.
closest the closest branch that we can get these tubes is still in Singapore, which will still take about a week or two in order to arrive here. But then everything else, like the battery pack, the cables, the camera, you can get locally. Now with the Critter Cam, the National Geographic one, um, I I don't think we have. Well, currently, I don't think we have the expertise or the parts. Um, I don't think it's as accessible to build one here or even getting replacement parts. And that's why the National Geographic um, Exploration Lab, they always have these suitcases just filled with spare parts because also in the field it's hard to access these parts. So the Critter Cam at least is only accessible through the lending program. But if we can, build some replica of this tool that can be, DIY'd or made more accessible, and it would be great. It means that we have a longer time frame in order to study these animals and not rely on X months before we have to give it back. Um, which is also like one of the inspirations why we wanted to create our own version of the Nat Geo deep sea camera is that it's great to have these tools, but with the time frame given to us with the lending program, we're also limited um, with how long we can do the research. What if some unfavorable weather comes? And that means that you lose days with that equipment, days that you can't recover. But if you have these tools to your hands, like um, you can deploy as soon as there's good weather. So it's really important, I think, globally that people have access to technology. Lending programs are great, um, but it shouldn't end there. I think it should um, gradually go to giving these areas their own tech that they can use for longer periods of time.
Yeah, I'm not familiar with that. Like, we agree wholeheartedly. I'm not familiar with that program, but it does sound like if we know within our community of a DIY AOT critter cam that you would be interested. It sounds like that you wouldn't have to even build from. Maybe someone's already done the work, is what I'm getting at.
Yeah.
Yeah, okay. Good to know. That's helpful. Thanks.
Okay, lovely. Right now, if you guys are all right, we might transition to the meet and greet aspect. I mean, we're a small crowd, so we'll just stay in this room as opposed to going into breakout rooms. But before we do that, can we give Titus one huge round of applause from around the room? Awesome. Thank you so much, Titus, for being our featured speaker today.